Hello and welcome, my dear students, to my channel Mathematics Made Easy. This is Ms. Ruchika welcoming all my grade 9 elite math students to today's session on Module 1, Lesson 5, Indirect Proof. Today's learning objective would be to prove theorems about triangles by using indirect proof. And if you have been watching and liking my videos, a humble reminder, a kind request to please subscribe to the channel as it serves motivation for me to make more and more videos for you. So let's start with today's session with the vocabulary words of the indirect proof lesson today that we are doing. We have three words here. The first word is indirect reasoning, the second word is indirect proof, and the third word is indirect proof by contradiction. So, what is the difference? Let's understand. Indirect reasoning means a reasoning that eliminates all possible conclusions but one, so that the one remaining conclusion must be true. So, we are going to remove all possible conclusions which are not true, and we are going to reach to the one which must be true. That remaining conclusion we have to reach by the method of indirect reasoning. So indirect basically means something which is not direct. So we are going to follow a route which is different from the ones that you've been following till now. So this is what is indirect proof, where you assume that the statement that you need to prove is false. So we are going to begin by a contradiction, by an opposition. That is that what we need to prove is false, and then we will use logical reasoning and facts, mathematical facts, to deduce that the statement which you are contradicting contradicts a postulate or a theorem or an assumption, and therefore it is not to be it is not true. Therefore this method is called indirect proof, or it is also called proof by contradiction. Why contradiction? Because we are assuming what we have to prove to be false in the beginning. That's the assumption that we make, and then we use logical reasoning, mathematical assumptions to prove that it is not at all true. So it's like an indirect way of reaching to the same goal. That's why it has the name indirect reasoning, indirect proof, or proof by contradiction. So let's see what kind of questions can come from this lesson and how you are going to use this indirect reasoning for solving them. Okay, so as you saw, in an indirect proof or an indirect proof by contradiction, one assumes that the statement that we need to prove is false. We are going to do the opposite of what needs to be done, and then we'll be using logical reasoning to deduce or to conclude that the statement contradicts a postulate, a theorem, or one of the assumptions. So assumption is something that we will assume in the question to be true in step 1, as you would see, and once a contradiction is obtained, one concludes that the statement that was assumed false must be true. So that's why it's called indirect. We begin by taking that the assumption is false, and we conclude that it is not false but true. That's why it's called indirect. That's why it's called contradiction. So step 1 is to identify the conclusion that you are asked to prove. So in the question, actually, as you would see in a few slides from now, that you will be given what you need to prove. So that proof you are going to take the opposite as the assumption and say that the conclusion is false by assuming the negation. Negation is like the opposite. And finally, you will go to step 2 to use logical reasoning, your mathematical assumptions, to show that this assumption leads to a contradiction. It leads to an opposition of the hypothesis. Hypothesis is like what is given to you, okay, in the question, or some other fact such as a definition, a postulate, a theorem, or a corollary. Any of these, if it is opposing, if it is differing, then you say that this step is done. In step 3, you state that because the assumption leads to a contradiction, it leads to an opposition of the original conclusion, what you were asked to prove. Therefore, initially, which we had assumed that the conclusion is false, cannot be there, and it must be true. So that's why it's called indirect proof, as we are doing the opposite of what is required. Now, more than what I've been saying till now, you'll understand more through this example. So let's look at this example. Write an indirect proof to show that minus 4x minus 4 less than 12. If this is there, then this is there. So look carefully. This is given to you. If this is true, then this is true. That's what you have to do, and you have to prove this indirectly. So this is what you need to prove, as you can see from the question. So you were given something. This given something is called hypothesis. What is the hypothesis? What is given to you? First step, you write what is given, that is minus 4x minus 4 is less than 12. This is given to you. Then what you need to prove? You need to prove, step 2, x is more than minus 4. Now in the indirect proof, you are going to take the negation, you are going to take the opposite of what you need to prove. So because you need to prove x is more than minus 4, you will take the opposite, that is x is less than equal to negative 4. This is called opposition. This is called indirect proof. So let's assume x is less than equal to minus 4. That means it has two options. One is x is less than minus 4 or x is minus 2. This is true. This is our assumption that we are making. Now this assumption is coming from the opposite, from the negation, and as we move forward to step 2 and 3, you will realize that this is not possible. So this is case 1, this is case 2. Next step. Okay, so in step 2, you have to contradict the hypothesis. So let's take case 1 where x is equal to minus 4. Now, when x is equal to minus 4, let's calculate the given part. This one, how it will be. Minus 4 times minus 4, I'm substituting, I'm putting the value. So this comes out to be 4 with 4, negative negative becomes positive. This is 16 minus 4, which is 12. So this 4x minus 4x minus 4 comes out to be equal to 12. But in the given part of the question, it was given that minus 4x minus 4 has to be less than 12. So is this holding true? No, it is contradicting the assumption. So the given information is contradicted for x equal to minus 4. So this is not possible. So what did we do? We used what was given here to show that this case x equal to minus 4 is not possible. Now let's look at x less than minus 4. So if x is less than minus 4, then minus 4x would be greater than minus 4 times 4, means minus 4x is greater than 16. Inequality sign is changed. Now minus 4x minus 4, we are subtracting 4 from both sides, is greater than 12. Now is this possible? What was given to us? It was given that minus 4x minus 4 is less than 12. So this is again a contradiction. This is not possible. So the assumption contradicts the given information for this case also. So what does that tell you? The step 2 concludes that the assumption is getting contradicted. The assumption leads to a contradiction of the given information that minus 4x minus 4 is less than 12. So the assumption that x less than equal to 4, the one that we did in step 1, must be false. It's not possible. So the conclusion, x greater than equal to minus 4 must be true. So this is called indirect proof, where we do the proof by the method of contradiction, by taking the opposite. So that completes the question. Next question on indirect reasoning is example 2 from your math book. Marco hiked at least 10.5 miles on a path, making just 2 stops along the way. Use indirect reasoning to prove that he hiked more than 3.5 miles on one leg of his hike. So, what is the total distance he has covered? At least 10.5. That means greater than 10.5. Minimum is this. making just 2 stops along the way. So if he is covering this total distance, then he is stopping at 2 parts. So that means there are 3 parts to the leg. So let x be the distance he is traveling in the first leg, y be the difference he's traveling in the second leg, and z be the distance he's traveling in the third leg. So third leg, first leg, second leg means the parts of the hike. So these are the total 3 parts of the hike. Now in these 3 parts of the hike, he's covering total how much? X plus y plus z distance, and it is given to us that this distance is at least 10.5, so it has to be greater than this. This is the first thing which is given. Okay, so that is coming from here. So given this thing, I hope you have understood how we get this. Now to prove, what we have to prove, that he hiked more than 3.5 miles on one leg of his hike. So each of them, x, y, z, are more than 3.5. Let's go with the indirect proof. So for the indirect proof, step 1, we make an assumption, and as you know by now, the assumption will be opposite. We are doing the method of contradiction. So this contradiction tells you that instead of x greater than this, what we need to prove, we will assume x is less than equal to this. Similarly, y is less than equal to 3.5 and z is less than equal to 3.5. So assume that no leg of the hike is more than 3.5. We are taking the opposite in step 1. Now, step 2, we need to contradict the hypothesis. So, if x is less, y is less, z is less, then their addition will also be less than 3 times, which means their addition will be less than 10.5. Is this possible? Look at what is given to you. It's given to you that the sum of x, y plus z is more than 10.5. So, this is opposite. So, it is a contradiction. It contradicts the assumption. So this is a contradiction of the given statement. Therefore, the assumption is false. It's not possible. Therefore, x is more, y is more, z is more than 3.5, and total Marco traveled more than 3.5 miles on one leg of the hike. So I hope you are becoming more comfortable with the method of indirect reasoning, and you are getting comfortable with the 3 steps, step 1, 2 and 3 of the question. Okay, write an indirect proof to show that if x square is an odd integer, then x is an odd integer. So what is given to us? If this is an odd integer, this condition is given, then we need to prove that x is also an odd integer. This is what we need to prove. So let's write step 1, given x square is an odd integer. This is what is given to you to prove x is also an odd integer. Now what could be the opposite of x is an odd integer? Indirect proof. So we'll assume that x is an even integer. That would be the opposite. So opposite of odd is even. So we are assuming that x is an even integer. To assume x is an even integer means it is a multiple of 2, because 2 is the smallest even number. So x can be written as 2k for some integer k. Now if x is 2k, then how much is x square? 2k whole square. Just substitute and this becomes 4k square, which can be written as 2 times 2k square. Now because k is an integer, 2k square is also an even integer. Let n represent this, then this can be written as 2n, where n is 2k square. So this means if x square is an even integer. Now is this possible that x square is even? Because we have assumed that x square is odd. So if x square is coming out to be even, this is contradicting the given statement that x square is odd. So is this possible? That means our assumption is wrong. That means x even is not possible. It leads to a contradiction. Therefore, the original conclusion that x is odd must be true. So this is called your indirect proof or proof by contradiction. You can use it in number theory in this way by reaching to a contradiction. Okay, next let's do an indirect geometric proof. If the angle is an exterior angle of the triangle, prove that the measure is greater than the measure of either of its corresponding remote interior angles. Corresponding remote interior angle means its opposite interior angle. So for example, you have this triangle MNO, angle 1 is exterior angle. Exterior means outside, so it is lying outside the triangle. So exterior angle. Then what are its interior opposite angles? Angle 2 and angle 3. So angle 3 and angle 4 are the interior opposite angles. Now I hope you remember exterior angle theorem. In case you have forgotten, I will repeat for you. Angle 1, which is the exterior angle 1, is equal to sum of interior opposite angles. So this is what you have to keep in your mind. We are going to use this exterior angle theorem in the proof of this question. So let's see what is given. It's given that angle 1 is an exterior angle of this triangle. So it's lying it's lying outside the triangle MNO. Now you need to prove that angle 1 is greater than angle 4 and angle 1 is also greater than angle 3. So we are going to take its opposite because we are doing indirect proof. We are doing proof by contradiction. So we will assume that angle 1 is also less than angle 4 and angle 1 is also less than equal to angle 3. These two are going to be this. So what does that mean? It means angle 1 is equal to angle 4 and angle 1 is less than angle 4. These two possibilities. So let's take case 1 where we take them to be equal. If they are equal, then by exterior angle theorem you get angle 3 to be 0. Is it possible that angle 3 is 0? This contradicts the fact that you have an angle 3 here which is having some measure. So this contradicts the fact that the measure of any angle of a triangle is greater than 0. So this is not possible. That means angle 1 and angle 4 are different. Next case where angle 1 is less than measure of angle 4. So again by exterior angle theorem, if you see measure of angle 1 is equal to measure of angle 4 plus measure of angle 3. Now because the angle measures in a triangle are positive, the definition in equality implies that measure of angle 1 is more than measure of angle 4. Is this possible? This is again contradicting the assumption. Therefore, our proof that measure of angle 1 is less than measure of angle 4, this is contradicted. So if this is more, it is leading to a contradiction. Therefore, that means the assumption that we made here, this assumption is wrong. So we have the assumption that measure of angle 1 is more than measure of angle 4 and measure of angle 1 is more than measure of angle 3. This must be true. So this is called proof by contradiction or indirect proof. So what did we do? We took an assumption and then we use the opposite of that assumption. We use the converse or the indirect proof to show that this is not true. So this concludes the lesson, and that was all about example 4 and all about indirect proof.